Notch3 mutations causing CADASIL can be a loss of its normal function, or it could be because there's a toxic accumulation of something that shouldn't be there. We don't know yet. Also of note that I want to point out here is the work that we're doing to understand the function of Notch3 and CADASIL is very important, obviously, to develop therapies for CADASIL, but it also turns out to have huge implications for how we potentially manage small vessel disease in general. So this is a type of stroke that affects at least 25 to 50% of stroke victims. And what I want to show you here are a couple things. That first of all, it's frequent, small vessel disease. Second, that it's a major cause of stroke and dementia. And third, that at this time there's no real good management. In fact, the stroke trials have been probably as successful as Alzheimer's trials, which are not successful. So they have a lot of interest in knowing what we can do from the genetic modeling perspective to learn more about small vessel disease, and they consider CADASIL as a potential small vessel model. And I just want to show you just to demonstrate the similarities, because the same type of vessels are involved in both diseases. You can see similar clinical manifestations, pathological manifestations, and here at brain MRI, I couldn't distinguish between the two. And here's an example of just how these are similar even in a pathological sense. So here's a normal brain, an aged normal brain. And the brown is standing for a smooth muscle cell protein. So it's giving you an idea about how intact those smooth muscle cells are within the vessel. Here's someone that has typical small vessel disease with high blood pressure, diabetes, etc. There's an abnormality. They do not have a coherent strip of smooth muscle cells. There's loss of smooth muscle cells. And similarly in CADASIL, there's loss of smooth muscle cells. So this led to a study which I'll talk about by an investigator at Harvard just a couple of years ago, who was able to show that if you can somehow boost signaling to Notch, you can actually rescue some of this loss of smooth muscle cells. So that's a really interesting point. So this is a biologically, clinically relevant readout of dysfunction, the loss of smooth muscle cells in the vessel, and by increasing Notch signaling, you can rescue